Hello, my name is Kalman Kumar. So this is my interview report of SOS, and my topic is TSC. So I am going to explain uh, graph topic. This is one of the most important topic in DSA. So now let us start. So graph is a combination of node and edge. So suppose this is two node and this is connected so by edge. So this is a graph, and also single node is also a graph, and combination of many nodes also graph. So there is two type of graph. One is unidirectional graph and second is directed graph. So undirected graph, uh, there is uh, both side direction. You can say like this and also like this. And directed graph, there is only one direction, like this, like this. You can say either this or this. There only one of this. Now come to representation of graph. So there are two methods to represent a graph. One is adjacent matrix and another is adjacency list. So now let's come to matrix representation. So suppose this graph as example, and I want to represent a graph in matrix form. So I write matrix index from 0, 1, 2 to 5, and similarly 0 to 5. So suppose here 1 and 2 is connected. So this is unidirectional graph. So this is connected in both directions, and say so here 1 and 2. So this is connected. So here till 1. Similarly, 2 1 is also connected. So 2 and 1 till 1. And similarly here 3 5 is connected. 3 5 till 1. Similarly 1 3 1. So 3 and 1 till 1, and 3 4 3 4 till 1, and the remaining which is not connected, leave it blank or can be 0. Both is okay. So this is matrix representation. So here is code. So take input n and m. So here n is number of node and m is number of edge. So here taking n plus 1 because starting index from 0 to n. Similarly, number of edges 0 to n. So here on for loop, take u and v as input. So u and v will tell the node. So suppose 3 and 1 is connected. Take it as u and this is v. So this is connected. So take a matrix value of suppose 3 and 1 as it 1. So this is connected. So here take 1. If not connected, then take 0 or leave it blank. Suppose so this is from U to V, like 3 or 4 connected. So this, and similarly in unidirectional, it may be connected from 3 4 to 3 or 4 to 3 in both directions. So here I am here taking UV and VE. So this one so undirected graph. If I want to represent only directed graph, then only take this and comment this. So its time complexity is so here n and vertical also n. So here is n cross n. So n square is time complexity. So this is a very large time complexity. So there is another method, and that's why list method come to minimize time complexity. So now take example. Suppose for this same graph. So there is 1, 2, 3, 4, 5. So here I make a list. So 1. So this is unidirectional graph. So Here 1 is connected to 3, so fill 1 fill with 3, and also can say 3 is connected to 1, so also fill 3 with 1. So here 1 connected to here, so 1 is connected to 3 and 3 is connected to 1. Similarly for 1 connected to 2, so 1 fill 2, and 2 is connected to 1, so in 2 fill 1. And now 2 is connected to 4, so fill 4 in 2, and similarly 4 connected to 2, so in 4 write 2. Now also 4 connected to 5, so 4 connected to 5, so fill 5 in 4, and similarly can say 5 is connected to 4, and also 4 is connected to 3, 4 is connected to 3, and 3 connected to 4, and can say 3 is connected to 5 also, and 5 is connected to 4 uh, and 3. So this is list representation. So list basically start from index 0, 1, 2, 3 like this. So here I take 0. So 0 it's represent nothing. So from start from 1, 3, 2. So it represent 1 is connected with 3 and 2. Similarly 1, 4. So here 2, 2 is connected to 1 and 4. Similarly all. So this is a list representation. So here can see time complexity is n, and in matrix is n square. So this minimize time complexity. So this is one of the better solution, better representation of graph. Now come to pet, petted graph representation. So first let's define what is the weight of graph. So here 1 is connected to 2. So there is some weight. Uh, so this number represents weight of this connected node, so not connected by edge. So if I suppose I write nothing here, so that will show by default one bit between these two nodes. So here represent this is here 3 bit for 3 and 1 and 6. So this edge and this number represent weight. So now come to the undirected graph and directed graph. So it's similar like so in matrix form. So take UV. In previous way, I am taking adjacent UV is equal to 1. So this represent connected. So this is also can say 1 represent bed. So here UV right bed. So this will represent the node U and node V connected with H, and that weight is WT. And similarly for undirected V to U, and for undirected remove any either of one. So here UV is equal to weight. So here uh, can say here in list form. So represent in list form. So here storing as a uh, pair of node and a head edge. So here this is the list of pair. So each pair represent, first one represent node and second one represent bed. So this is all about graph. Now come to the tree. Uh, I am also explaining about the tree. Tree can say uh, tree is a part of graph. So in graph we connect any of another node. We can connect multiple nodes and all are maybe interconnected. But in tree there is one node and all another node connected to this like this. So here is example. So this is called root, and all this is called children. So here this is left children from here to here, and this is right children. So last one is called leaf node, and this is binary tree. Also can here relate. Binary means two. So here from one node there are two edge connected, two node connected with edge. So also can relate from here. This is binary tree. So there are many types of binary tree. So this is complete binary tree. It means each level are filled, completely filled. Suppose if I remove this node, then then we cannot say this is this is complete binary tree after removing this. So all levels should be filled. So in almost binary tree, what happen like uh, from from left to right, nodes should be filled like this. So this is called almost complete binary tree, and you can say this is not complete binary tree. And suppose I remove this one, and these two remain same, and remove this, then it will not say almost complete binary tree. Perfect binary tree. So perfect binary tree, uh, theory definition: binary tree where all leaf nodes are at the same level and number of leaf nodes is maximized for that level. So suppose there is one node, so this is level one, and there is second node connected, so this is level two. So suppose I have to I have two level and maximize the number of leaf. So suppose I connect only one leaf, and so this not maximum, and when I connect two node, so at one node uh, we are connecting two leaves, that is the maximum. And also this fulfill the level, and also uh, this maximize the number of leaves. So similarly here, all level are completely filled, and this maximize the number of leaf also. If I suppose I remove some leaf, so that will not a perfect binary tree because that not maximize number of leaf after removing this. Now come to balanced binary tree. So this one is one of the important. So balanced binary tree, it is type of binary tree where height of two subtree of any node differ by at most one. This property ensures that tree remain relatively well balanced and preventing tree becoming highly skewed or degenerate. So here one root is connected. So there is two sub branch. So we so actually in this from here to here, this is called height. So here we try to minimize the height difference between two sub branch. So in this example we can see height is same, and in this example see height there is a difference in height. So in second branch there is up to two level, in first branch up to three level. So this is the minor difference in height of this tree, and here difference is zero. So this tree is more balanced compared to this. And suppose I remove this two leaf, then the level difference will be two. So this will be more unbalanced compared to this previous. And there is a degenerated tree. So we also can say skew. So here what happens? Uh, the root is connected into either one side. Or can say this is more a skewed tree, and there is a in simple what can say uh, root is connected by uh, sub branch in one side, and this may maximize the height of the tree. So here is representation. So this is root and connected. absolutely like that. Thank you.